Okay guys, so for supercapacitor or supercapacity, the second step is to measure the specific capacity or specific capacitance using the cyclic photometry analysis. So here, what you need to do is you just need to input the potential, starting potential, vertex 1 and also vertex 2, how it's going to end. So in my cases, my CV will start from 0 and ended to 0.5 or 500 millivolt. So it depends on your sample. First, if you didn't know what is the potential window of your sample, you can run a big potential window, for example from 0 to 1 volt or 2 volt. If your sample is battery type, you must observe redox peaks here. If your sample is EDLC, it's just a rectangular shape. So depend on your sample. So based on journal also, you can know the potential window and test. For example, you read from journal, your potential window is 0.5. So you can start from 0 to 0.5. If you want to extend, for example, until 0.6 or 1 volt, you can see the straight line indicating oxygen and hydrogen evolution. You can check. Okay, so the important thing is to know the potential window. How to know? You can check by widening the potential window. Okay, then the important things also about the scan rate here. The scan rate indicate how fast you scan your CV. This is 5 millivolt per second or 0.005 volt per second. So you can scan a lower scan rate or higher scan rate. So normally we scan 5 or 10 or even 100 millivolt per second. It depends on your sample. So make sure understand about the potential window. If you going to calculate the specific capacity or capacitance, the potential, the scan rate plays an important role. The lower the scan rate, you can get a higher specific capacitance or higher specific capacity. Why? Because at higher scan rates, you can see at higher scan rates, the electrolyte have enough time to penetrate the material, all active side of the material. Depends on the higher scan rate. They doesn't have enough time to penetrate all the electroactive sites. So the scan rate also plays an important role. But for preliminary study, just fix only one scan rate. If you already get the optimized sample, you can play around with multiple scan rate. So at this second tutorial, we just want to say, after you weight your sample, first weight the empty substrate, then weight your sample, then you can get the mass of sample by minus the weight of sample with the substrate. You can get the weight of your sample. So what you do is, you keep in mind for the weight first, then you run the CV analysis. From the CV analysis, observe the number one is the shape. For supercapacitor or supercapattery, they have their own shape. So if you can see very obvious redox, this is battery type material. If you didn't see a very clear redox, for example, you just see a distorted CV, for example, it's just like a leaf shape, it's a criteria for pseudocapacitor. If you get a very good rectangular, so that's one for EDLC based material. So depends on your shape, you can know your material suitable for what application. So there is a law for supercapacitor, pseudocapacitor, and also supercapattery. For supercapattery, the one of the electrolyte, which is the positive electrode, should have the battery type material. They should have this shape, which is redox shape. Okay, so the important thing about the CV, you must include the vertex 1, which is starting potential, vertex 2, which is how it's going to end, which is 0.5. So if your material is different, you can scan from higher potential window, for example from 0 to 1 or 0 to 2 volt. And you can cut off the potential window if you see hydrogen or oxygen evolution. Means that you can see a very straight line, the very sharp straight line. So it's not good. So you just going to take the potential window where the redox process happened. Then also important thing about the scan rate, for the preliminary study, just fix the scan rate. Okay, after that, so how we going to measure the specific, for example, this is battery type, I'm going to measure the specific capacity of this material. So here, I run for 2 cycles here, so I just click the second cycle. Normally we take the second cycle. Okay, so I just click the copy data and text. So what I'm going to do is I'm going to go to the Excel. For example, this one, I'm already paste it, so I just copy. Okay, what I'm going to do is I just going to click the analysis button here. So just click the integration. Okay, integration. So next, they will automatically calculate the area under the curve. So this is the area is 0.016. You just copy the area only, and you must make an Excel. Okay, from the Excel, you just paste the area. Okay, for example, the mass that I get is 0.0005. So this is the mass that earlier that we measure our sample. So you can get your specific capacitance 850 and your specific capacity is around 425. So from this table, the important thing is to know about the area that we can calculate using origin. Scan rates, if you run 5 millivolt per second, you can enter 0.005. This is in terms of volt per second. Potential window, mass, the important things that the first thing that we did. And also you can get the CSP by using the formula of the area divided by scan rate, potential window and mass. For the specific capacity, area divided by scan rate and also the mass. You don't have to include the potential window for specific capacity. So I think that's all for the second tutorial, how you can calculate specific capacitance or specific capacity based on your material. Okay, it's quite simple and straightforward. So the formula is for specific capacitance, area divided by scan rate, potential window and mass, while for specific capacity, area divided by scan rate and also mass. That's all. Okay, see you again. So hopefully you can understand. Okay, bye.